and that's quantum computing. And if you dive into this field, it's absolutely fascinating. Quantum phenomena are unlike anything you'll ever observe in unless you're looking through an electron microscope or in a particle collider. And I'll give you an example of one of the strange attributes of quantum phenomena. Back in the day, Einstein predicted that there would be particles that behaved in a way that was, as he called it, spooky at a distance. So what does spooky mean? It means that a given particle will align with another particle and turn in the same direction to maintain the same orientation, no matter how far apart those two particles are in space. When I say no matter how far apart, like they could be on one side of the universe and the other side of the universe. And when John turns right, the particle named Harry also turns right. So it's a very strange phenomenon, that's all I can say. And you might say, well, this is kind of scientific and interesting, but has no application in the real world. And it turns out that's not as true as you might think. One of them is something called quantum cryptography, which exists, but probably the more tangible item is a satellite the Chinese launched using entangled particles as a communications device. And the beauty of using entangled particles to communicate is there's no apparent signal back and forth between the two particles, and therefore there's no way to intercept the signal. And of course, over time, they're going to figure out ways to make these operate at enormous distances and through little annoyances like the Earth without a problem. So it's interesting to see they've taken this thing that had lived in labs and in people's minds for 50 years and actually been able to begin to put that into the real world. The other aspect of quantum is quantum computing, and it does rely to some extent on the concepts involved in entanglement, but also is predicated on this thing called a qubit, which is a form of matter that can, for example, be a 0 and 1 simultaneously with superposition and other quantum phenomenon. You can actually get that individual particle to embed a number of different dimensions of information. So while we're looking at a traditional computer where the semiconductor is going to have to be turned on in zeros and ones, a quantum particle can be 0 and 1 simultaneously. And as I understand it, and I'm pretty sure I don't fully understand it, it can also embody other states as well, so that it could have 6, 8, 10 pieces of information in that single particle simultaneously, which means it's very powerful and very fast for certain kinds of applications. Google recently announced that it had not only built a quantum computer, but it had actually run a quantum test to determine what's called quantum supremacy. And that term embodies the concept that the calculation done with the quantum computer could not be done in any reasonable amount of time with conventional computers. So in this particular case, they did a calculation that would take 10,000 years of normal computing and did it in a little over 33 minutes. So it is a huge breakthrough in terms of sheer compute power. Although I have to tell you, the underlying exercise was generating numbers, which didn't strike me as a particularly meaningful application, but nonetheless, it was a proof of concept on a scale no one has ever done before. So, okay, Google's got it in a lab. It turns out that that's not only true, but other people are actually building quantum computers as we speak. And this is D-Wave Systems. They're making these, they're time sharing them. And interestingly, Amazon is going to be offering quantum computing services as part of its cloud-based compute service platform. So this stuff is being built now, it's being offered now. You could actually get on and use a quantum computer on a time-shared basis as we speak, which I just, back 5 years ago, I couldn't have imagined we'd be doing that. So as we turn to say, how else is this, showing up? We're starting to see some very, very nascent signs of jobs in quantum computing. Some of them still in labs, most of them still in labs. But outside of academia now, some of the cutting edge companies, whether it's Goldman Sachs or Booz Allen, are investing in people to build quantum systems within their organizations. So this is beginning to show its head in the job market, but realistically, we're still talking about 250 jobs in the country. So this isn't a large field of employment right now, in part because there are very few people who are capable of being employed in the field. So I actually think the cutting edge of this program, if you will, is going to be in higher ed, actually training people in some of the skills needed to do quantum computing. So as we turn page, these programs do exist. This particular program is at University of Wisconsin in Madison. Part of the physics program, they are now teaching quantum computing and training people in the conceptual, mathematical, and experimental knowledge required to run quantum computers. And this is no easy feat. The software to run a quantum computer is fundamentally different than the software required to run a von Neumann process, I think it's called. And so we're really building the operating systems and the computer languages that will be required to run these efficiently and effectively, and beginning to run the very first applications and tests and simulations and such. So a lot to be learned here, but the programs are beginning to be put in place at certain universities. And where you can also see this moving forward is actually on edX and other online MOOCs. It might seem like a strange place to find something so advanced, but actually in our experience, if you're trying to find the cutting edge, oftentimes it'll show up on the MOOCs first because the barriers to entry for launching a program on a MOOC are very low. You're outside of the normal regulatory environment. You're often outside of even the internal university's normal process for approving programs, and you can reach a global audience. So you do see some of these very advanced things showing up in the MOOCs first, and quantum computing is no exception, with the university in Denmark, Delft-X, offering a few, not full programs, but courses here, and a number of other universities beginning to show up on the MOOCs, teaching people about quantum learning and quantum technologies.